All right. That's cool. All right. Welcome to our talk, Better Concepts, Less Code. My name is Tobias Bosch. With me is Victor Savkin. We're both part of the Angular core team. In this talk, we will show you some advanced concepts. They are powerful because they solve common problems in an easy and an elegant way, I'd say. Let's get started with an example. So let's say we want to do a conference. So we need an application to manage it. So we need something to manage talks. Here we have a list of talks. We want to manage some speakers. We need some navigation. For the navigation, we use a tab bar in this case. And in the following, we will walk you through how to build these components and what challenges we find with them. So let's first focus on the tabs component. So it looks like this. We have titles on the top. And whenever you click on one of these titles, the corresponding content shows up. So you click on speakers, then the list of speakers shows up. You click on talks, then the list of talks shows up. As a user of the component, when I code this application, I want to be able to use the following markup that you see here. So I want to write a tabs element, and inside of the tabs element, I want to put pairs of tab title and tab content. So when the title is clicked, the corresponding content should show up. All right, so how do we write this? So first, we need an application component. In Angular, everything is a component. Not everything, but you start with components. Your application itself is a component as well. Right, so we have this application component. We put the markup in there that we want to use. Next thing we need is the tabs component. So you see we have a selector that matches the tabs element, and we have a simple template in there. It's just a div with a class on it. That's the navigation bar on top that you saw, but it's empty. Let's run the application. If we run it, we see something like this in the DOM. When you would inspect it with the browser tools, you would see the document. Under the document, you would see the app element, the tabs element, and inside of the tabs element, you would see this navigation bar, this div. But you would not see any tab title or tab contents. Why is this? So when Angular creates a component, it takes the nodes that it finds in the template and makes them children of the element of the component element. So in this case, you can see we took the template and just made it children of the tabs. But the original children, they were just removed by Angular. So what can we do to actually show the tab titles and the tab contents? And we also want to group them. All the tab titles should go in the navbar, and all the tab contents should go outside of the navbar, right? So for this, Angular 2 has a new concept called ng-content. So ng-content selects elements that you place in your application components by using a CSS selector that you place in the select attribute. So in this case, this ng-content selects all the elements that match tab title as CSS selector, which is 2 elements, the one I marked. And when we run this application again, we will see these 2 tab titles show up at the place of the ng-content. And in this case, inside of the navigation bar. So we can do the same for the tab content. Like we put an ng-content outside of the navigation bar. And with this, we would group the tab content outside of the navigation bar. If you know Angular 1, this is called transclusion in Angular 1. And if you know web components, they have a content element, just a content element. Our ng-content is a little different. That's why it's called ng-content. Right, so that works. That's nice. So let's have a look at the next part of this tabs component. We have a button on top, next tab, with which we can cycle through the tabs. So you click it once, and it steps through them. And we have an extra feature to show events, like an extra tab, but conditionally. So first, we don't have events, and then we can cycle through the 2 tabs. We show events in the middle, and the cycling happens in the correct order. This is what you expect, right? So first talks, then events, and then the speakers. There are some challenges with this. Let's have a look. So we start off with the application. I left out the tab contents for now, just for simplicity. We have a tabs component, a tab title component. And if we run it, you'll see we have one instance of the tabs component, I denoted it with class and then pound and then a number, and 2 instances of the tab title component. Like here on the right-hand side, you see the instances. So 2 instances of tab title component. Good. So for this next tab, if you think about it, it's a button, so we probably need a method in the tabs component called next tabs that does the trick. What else do we need for this to implement it? So we probably need a list of tab titles in the tabs component. And let's say the tab title has a show, a hide, and a is visible method. With this, you could imagine how next tab works. You go through the array of tab titles, find the one that's visible, hide it, go to the next entry of the tab titles array, and show it. So that's easy. The tricky part is, how can the tabs component get hold of the tab titles? For this, Angular 2 has a new annotation. We call it content children. If you place this on this property, tab titles, and you run the application, then you'll see that Angular fills this array automatically for you. And it fills it in the correct order. So let's say the application puts 2 different tab titles in there, an orange one and a light blue one. Then you'll see the instances showing up in this array also in the correct order. First the orange and the blue one. And the interesting part is, let's say we have this middle tab, like this events that was shown or hidden, triggered by an ngIf, for example. Then this will also show up at the correct place in this array. So you don't have to care for this. Always correct order, always up to date. So let's look at this content children a little bit more. So why is it called content children? So let's generalize our case that we had. We have a tabs component. In general, it's a widget that you want to reuse, right? So here, let's say we have a my widget, whatever it does. Let's not care. And the my widget uses a component B and its template. And let's say we have an application that uses my widget on the left-hand side and places a component A inside of it. So now we have kind of 2 different kinds of children. Component A is placed by the user of the widget as a child, and component B is a child of my widget, but placed there by the author of my widget. And we have, in Angular 2, we have 2 different names for these. So there are the instances of this when it's live. We call component A content child of my widget, because you could select it with ng-content. Right? This was exactly the relationship we had between tabs and tab title. And the other one we call a view child. We call it view child because when Angular instantiates a component, it takes the template, clones it, and the result of instantiating a template we call a view. So it's a child that lives in the view of the component. That's why we call it a view child. So and then we actually have 2 annotations. We've got content children, with which you would get the instances that a user of your component would place as children. And we have view children. These are the children you placed inside of your template yourself. So that's the different names, content children, view children. And there's one more thing. So this query list here, maybe you saw it. It's not an array, right? But it's similar to an array. It's iterable in the sense you could use it in a for-off loop. It implements the iterable interface. And it has an observable. It's a property changes. So you can subscribe to this observable and get notified by Angular when the content changes. Right, and last point here is there's view children, but if you know you just want to have one, you can say view child or similar content child. If you know there's exactly just one. So you don't have to deal with iterating through the array and stuff. Then Angular either fills it with the correct instance or with no. So let's compare this to Angular 1. What are the corresponding concepts in Angular 1? So projected content children, this you know as transclusion in Angular 1, right? In Angular 1, though, you can just take all of them or none of them. You would use ng-transclude, and at the place of ng-transclude, all the children would show up. But maybe you heard the new Angular 1.5 release will have a similar concept like this. It's called multi-transclusion, I think. And you can have multiple slots and place different elements at different places in your template. The concept here with ng-content is a little bit more powerful, though. Because first, its performance, it has no impact on performance because we can pre-calculate it during compilation already. And compilation in Angular 2 will eventually be a build step. So there's no CSS selector matching going on later on. And second, this works for all renderers. So this works with the DOM. This also works with native script. Like if you create native elements, it works there as well. The second concept we saw were these add content children or add view children. If you look at Angular 1, Angular 1 does not have this concept. Angular 1 only allows you to get hold of the parent from the child. So the child can ask, give me my parent, but not the other way around. If you want to have this list of children from a parent, you need to implement it in your own way. Probably you did it. So the child calls the parent, hey, add me to your list. When it's destroyed, remove me from the list. And to get the right order, in Angular 1, you had to fall back to the DOM, do some query selector all stuff to order the children in the right way. So it was super painful. It was painful, it was slow, and it also created bidirectional relationships. So the parent needed to know about the child, but the child needed to call up to the parent, so they were tightly coupled. Angular 2, just one of them. Just the parent says, I want to have the children, but the children don't care about the parent. Right, with this, I hand over to Victor for the table component in this example.
Right, cool. So Tobias showed us how we can use the Angular 2 primitives to build the tabs component, how easy it is. So what I want to show you is how we can use the same primitives to build the conf talks component, the list you saw in the first tab. The component will display a list of conference talks with a filter at the top. So it will look like what you see on the left. The component has only one input property, talks, which is an array of data that looks like this. So it's an array of simple JavaScript objects where every object has an ID, title, description, and speaker. This is how the component should work. So it should display the list of talks, and the developer who uses the component in her application should be able to customize the way the component renders talks by providing a template. So in our case, the template is very simple. We just use a link and a paragraph, but it can be anything. So it can contain other components, so it can be interactive. And so this is very powerful. So this slide shows how we will use this component in an application. Now let's look at the actual DOM this component will generate. So it's simple DOM, just a form and a list. So it's what you would write by hand. Now let's think for a little bit what we need to do to implement this component. So the first problem we need to solve is how we get a reference to the template. Okay, the developer who uses the component specified. And then how we stamp it out. Doing it in Angular 1 is very hard, especially if you want the component to handle all corner cases and if you want the component to perform well. And if you think about it, this is actually a very common use case. Directives like ngIf and ngFor, they do exactly that. So they take their template, and then they stamp it out once or like many times. So in Angular 2, we have a special primitive that makes implementing such directives a lot easier. And it's called a template ref. So a template ref allows us to reference a chunk of UI, and then we can use a template ref to stamp out multiple copies of that UI. So let's use it to implement our component. All right, so first note that the component has a talks input, which is a passed-in data, that array. Right below, I use the content child decorator Tobias mentioned to get the template ref. Here, I could use template ref to manually stamp out that UI, multiple copies of the template. But in this example, I will just pass it to ngFor, and ngFor will do it for me. So ngFor will loop over that array of talks, of that simple JavaScript objects. And for every item in that array, it will create a chunk of UI using the provided template. So this is how simple it is. So there is no imperative code in this component so far. There is nothing here that needs to be unit tested. You can write an integration test to make sure that the component renders and it works and whatnot. But there is no logic in this component that needs to be tested in isolation. So in Angular 1, this is a fairly advanced scenario. It's hard to do. And in Angular 2, it's trivial. So this is everything we had to do to basically render our data using a custom template provided by someone who uses our component. Now let's look at what we need to do to implement the filter. And this is how it should work. So when the user types into the input box, the component should filter the array and show only the relevant stuff, obviously. But it should do this once there are at least 3 characters typed in. So we need to run some validations before we do the filtering. Also, we don't want the UI to bounce around too much while the user is typing. So the component should filter the talks only after the user is done typing for, say, half a second. OK? So to implement this behavior, let's start with adding an input box with a mean length validator on it. Similar to Angular 1, I could use ng model here and data bindings to pass data into the input and get it out of the input. So I could do that. It works in Angular 2, and it's a great way to manage input in many situations. But today I want to show you something different. So instead of using ng model, what I want to do is I want to get a reference to the ng form directive created by Angular. So this ng form directive will be created at that form element, where the form element is placed. And this is similar how Angular 1 does it. It creates a form controller, so in a way it's similar. So I will get this directive by using the viewChild decorator. And this is because the form is placed in the view of this component. So it's created by the template. That's why I use viewChild instead of contentChild. So we declare this form property, which will be sent after the view has been rendered. So we need to wait. To know when the view was rendered, we need to use the right lifecycle hook of this component. So in Angular 2, components have a well-defined lifecycle. And the component lifecycle is not like a new primitive, but it's a lot better defined in Angular 2. And this enables you to build rich components without writing defensive code, where you have to constantly check if a certain property is defined or not in certain situations. So since Angular 2 is more predictable and in general provides more guarantees, you can avoid writing defensive code altogether by using the right lifecycle hook. So this slide shows all the lifecycle hooks supported. And I won't dive deep into each one of them, just because it will take a lot of time. You can read more information about these hooks in the API docs and in the user guide. For this example, I will just use one of the hooks, called afterViewInit, which is called after the view has been rendered the very first time. And that's exactly what I need in my example. So back to our example. So we got our form, and we know it's defined in afterViewInit. So what I'm going to do next may look a little bit unusual for many Angular 1 developers. But if you learn this way of managing input and events, it will become a powerful tool in your toolbox. So it will make implementing certain scenarios like this one easier. So what I'm doing is I'm getting an observable of the form's value changes. And an observable in this particular case is just an object that will emit a new value when the input changes. So if I type into the input, a new value gets emitted. So there are a few talks at this conference that cover the subject of observables sort of in depth, so I won't go into it. If you're unfamiliar with observables, don't worry, just look at the shape of the code and look at how direct it is. Don't worry about the exact semantics, okay? All right, so the first thing I'm going to do with my observable is I'm going to filter out all invalid input changes, all right? Second, I will throttle it. So the observable will wait for half a second of inactivity before re-emitting a value. So the final observable won't emit any values until the input is valid, and the user stopped typing for half a second, all right? Finally, I'll subscribe to this observable and call the filter talks method in it. In this method, I will use the input property, which is that array of talks we saw. I will find the matching talks, and I will update the filter talks property of this component. The ngForm directive in the template will use this property to render the content. So this is everything we had to do to implement this interaction, to implement this component. We added a few decorated properties and 2 functions, 4 lines of code each. So that's it. That's pretty good. That's not much code. So in the interest of time, I won't build the same example in Angular 1 step by step. But at the end of the talk, I will provide a link to a repository where you can find the Angular 1 and Angular 2 versions of both components, the conf talks and the tabs components. So you can compare it for yourself. Now I just want to highlight a few things. First, rendering a list of talks using a custom template provided by someone who uses our component was trivial in Angular 2. And it's very hard to do right in Angular 1. And this makes a whole class directives a lot easier to implement. Basically, it will be useful anytime you want to really customize how a component looks. Second, if I want to add another filter to my component, the needed change, the required change is very small. I just need to add the required input and use the value of that input to filter the data. There is nothing else in the component I have to change. I don't need to subscribe to the second input, or I don't need to throttle it separately. It all works. And in general, I find it easier to write such components in Angular 2. We have a small change in the requirements, and the needed change in the component is small. All right, so we showed you how to build two components in Angular 2. And we tried to build the components in the most straightforward way we could. So we didn't use any hacks, and we didn't use any private APIs to build the components. We also built the same components in Angular 1. And once again, we tried to do it in a way that is intuitive to us, straightforward. Now let's compare how much code we had to write to implement the two components in Angular 1 and Angular 2. So I don't expect you to read the code because the font is too small. Just look at the volume of the code, the outline. The Angular 2 version is twice shorter. And if you remove the templates, because they are more or less the same and leave only JavaScript, the difference is even more pronounced, about 2.5 times. And this is important because you tend to have imperative logic in your JavaScript. Yes, you tend to have logic there that can be buggy that you need to test. And I usually argue against using lines of code because you can always game it. You can collapse a few things here and there to get 20% less code. But here it's different. And it's different for two reasons. First, we aren't talking about a small improvement like 20%. We are talking about 2.5 times or twice smaller. So that's a big deal. And remember, we compare ourselves to Angular 1, which is already an expressive framework. So this is a very good result. But what is even more important is that the Angular 2 versions are shorter, not because we use some hacks or special tricks, quite the opposite. They are more straightforward, they are a lot more direct, and they are a lot more toolable. So they're shorter because the framework provides better primitives for building user interfaces. So it's built out of better concepts. So to summarize, Angular 2 provides better primitives for building applications. It's very easy to project content in interesting ways. It's very easy to access children or customize how your components look by using custom templates, and more, obviously. All these things help you write a lot less code to build rich, interactive applications. Thank you.